Hello, I'm Allan Clarke. I'm a senior developer and architect with Lumina Networks. And today I'm going to take 5 minutes and I'm going to show you what ODL Plastic is and why you might want to use it. ODL Plastic is a project that is used for model-to-model transforming. It is a tool that is completely separate. There's no technical dependency on plastic to ODL. It can be used outside ODL easily, but it's included in ODL because the mapping problem is something that happens commonly when you're dealing with northbound to southbound translations between an abstract interface and devices. So what is the mapping problem? It's usually behind an endpoint. There's usually a north-facing endpoint that customers use. And then in the ODL context, it usually means mapping from an MD-SAL model into something that devices themselves can understand. This usually involves like some kind of usually trivial conversion of data, maybe from JSON to XML or the other way around. But sometimes it's more complicated. Sometimes the northbound user wants to send in one model and get one model out that's sent back to the device. Sometimes there are multiple different models that need to come in and be translated into the same model, or the inverse of that, and sometimes they're just different model-to-model translations. So Plastic can help you with that. So Plastic gives you relief for things like if schema changes. You can think about this as payloads when you're making REST calls to devices to configure them, that kind of thing. The vendor will often change those schemas between different release numbers of the software that runs on the device itself. And you can use Plastic to help you manage those changes to those schemas. In addition, if you use the vendor's libraries, they are often kind of hardwired to the schema, and there's no real good way to handle older versions. They don't, for example, the Java packaging, they don't handle that very well at all. So you can become independent of that if you use Plastic. And then a third advantage is that in the field, it supports updating. And the reason this is true is because there's an emphasis on non-coding most of the solution, as much of the solution as possible. So because it doesn't reside in code, the chances are that you can make changes to configuration files and that kind of thing in the field. So the advantages of using Plastic are that you get pay-as-you-go for complexity. That means that it means that if you have a simple problem, then you have a simple solution. And if you have a modestly complex problem, you have a slightly more complicated solution. But if you really need to get in there and do surgery on things, that is available as well. So basically the complication of the solution matches the complication of the problem. So another way of saying this is that for in the ideal case, you would actually do no coding at all. In the modestly complex case, you would do cookie cutter coding, which means you would look at some examples and you go, oh, I see how to do that. And you would use that as an example and modify it accordingly. And then in the worst case, you could actually get into coding. And the coding that, the languages that are supported are on the JVM, which means Java and Groovy and those kinds of things. The other thing is that there's a clear declarative representation for your schemas. So your schemas are usually declared in JSON or XML with some minor syntactic markings so that you can tell Plastic what to do. And the whole idea here is that you translate by intent. That means that you try not to code do this, do this, do this. You just say, this is a picture of what I want to start with. This is a picture of what I want to end up with. and then you, plastic, take care of this. In addition to that, plastic also understands how to break up large mapping problems into smaller chunks. It will, you do have to do a minor amount of coding to help it understand where to make the breakages. You can think of, for example, that if you were doing a query against a device and you said, give me all the alarms that have happened, in the last minute, each of the alarms might come in a different format because it's a different alarm type. And yet you want plastic to take all those alarms and normalize them. So you get this heterogeneous array of alarms coming in, and you want a homogeneous array of alarms going out. So plastic can help you do that. In addition, there are some features in it that let you take advantage of parallel processing so that it looks at the width of your machine and will allocate threads to help break up those large translations into smaller pieces in parallel. So should you use ODL Plastic? Well, if your mapping doesn't really change much and you're okay with coding it up in Python or Java or whatever, which is kind of brittle, then maybe you don't need plastic. If you have inexpensive programming time, access to that as a resource, then maybe you just keep paying your programmers to make changes, and that's okay. If you don't mind, so one of the issues with coding things up explicitly in a language like Java or Python, the issue is that if you get somebody in there and they say they want to understand what the schema, what the payload looks like, it's a little bit harder to see it when it's expressed as code. But in plastic, it's not expressed as code. And so it's a lot clearer to see it. So if you don't care about that, then you probably don't need plastic, okay? And then if you don't care, if you're not sensitive to regression failures, like through sharing of code and then breaking old translations, then you don't really need to plastic. And then the last thing is a note that plastic is appropriate for configuration time, surely, and then some control plane activity, it can be used there as long as the response time and the rate is not super high. But it's not, and it can be used in low and medium streaming contexts. But if you have a high throughput streaming, then it may not be quick enough for you. So you would have to try it out and see how that works for you. And then on the way out, thank you for your time. I wanted to add one more thing. This is what happens when you you don't have a good mapping problem. When you don't have a mapping solution. This is courtesy of XKCD, and it makes me laugh every time I've seen it. And this is probably the 100th time I've seen it. So hopefully you're laughing with me. So that's all I got for the introduction to plastic. Thank you very much.